All right, so this video is going to govern the activity series. Activity series is important for your understanding of your single replacement reactions. Thus far, as we've looked at balancing equations, we've just kind of assumed that if I give you reactants, products will form, which is not true. So the activity series governs whether single replacement reactions are actually going to occur. In order for a single reaction or single replacement reaction to take place, the single element has to be more chemically reactive than the element that's in the compound that it's attempting to replace. If it is more chemically reactive, the other part of the compound will actually leave what it's currently paired with and go towards the more reactive thing. But if it's not more reactive, they just sit there in a beaker together and nothing happens. So the actual chemical activity of the members of the reaction is important. So the activity series is a list of metal, which are your positive ions, and your halogens, your negative ions, in order of decreasing activity. So the most reactive species are on the top of the list, your least reactive species are at the bottom, and it's on your reference packet. So let's take a look at your reference packet. In our class reference packet, this is on the back, and there's two of them. So we have our activity series for halogens, and we have our activity series for metals. So important to note, remember that halogens are negatively charged ions, and metals are positively charged ions, and that's why they're in two different charts, right? You have to know when you're looking to see if a single replacement reaction is going to occur, which chart do I need to be on? Okay. And then once you locate which chart you need to be on, all you have to do is identify the positioning of your elements to see whether or not the reaction will take place. So when you're looking at activity series problems, right, before you go to the list, you need to ask yourself three things. It'll make your life a lot easier. First, who is my single element? Identify the single element. Hint, it's the thing that's not paired with anything, right? It's the thing that's by itself. Then what is the charge on the single element? Is it a negative ion or is it a positive ion? Because that's going to determine which chart you look on, right? If it's a negative ion, you're looking up here. If it's a positive ion, you're looking down here. And then identify who is it trying to replace, okay? And so when I identify what the single element is and what's it trying to replace, I then look at those two positions on my activity series. So let me zoom in here for a second. So for example, say my single element, let me grab some pens so I can point and not have my big old fingers in the way. Say my single element that I'm looking at is magnesium, but the element in the compound is zinc. Well, magnesium is higher up on the list, so it's more reactive than zinc. So yes, magnesium could replace zinc in a compound. But what if magnesium was my single element and potassium was in my compound? Well, magnesium is lower on the list than potassium, so magnesium cannot replace potassium. So a good rule of thumb is if you are above what you are trying to replace, it will work. If you are below what you are trying to replace, it will not work. Same thing on the halogens list, right? If my single halogen is chlorine and the one in the compound is fluorine, right? Chlorine is below fluorine. Chlorine can't replace fluorine. But if the one in the compound was iodine, you bet chlorine can replace iodine. Okay, so you have to look at the position of the elements on the table. Ooh, let me zoom back out. All right, so we're going to look at the two most common types of questions that I'm going to ask you about activity series, and then we'll go through and use the list. So the first type of question that I'm going to ask you is just, will the reaction occur and why? Which just means explain to me the relationship of the two things on the list. All right, so let's go back to those three questions I said to ask. Who is my single element? Well, in this case, who's my single element? It's the thing by itself. It's cobalt. All right. What's the charge of my single element? I.e., is cobalt a metal or is it a halogen? Well, cobalt's smack in the middle of the D block. It's a metal, so it has a positive charge. If cobalt has a positive charge, it has to try to replace something with also a positive charge. So positive compare with the negative. So look at my compound. Hydrogen is positive, chlorine is negative. So who is cobalt trying to replace? It's trying to replace the hydrogen to pair with the chlorine. So I need to look on my list at the relationship between cobalt and hydrogen. All right, so let's go to my list. And I'll zoom in. All right, so where is cobalt? Cobalt is here, and there's hydrogen. So cobalt is above hydrogen on the list. So cobalt is more active than hydrogen. So what is my answer then? Will the following reactions occur? Why? Well, yes, this works. And then the why is, tell me their position, because cobalt is above hydrogen. That's it. That's all you're doing. You're telling me why it occurs. Because cobalt's more reactive than hydrogen. It's above it on the list. So this is going to work. All right, let's look at our next example. First question, who's my single element? Oh, my single element is potassium. What's the charge of potassium? Oh, it's a positive. It's a metal. Who's it trying to replace? It's got to be trying to replace lithium. Lithium is also positive. So will the reaction occur and why? Let's look on the list. So I'm looking at, can potassium replace lithium? Well, potassium is lower on the list than lithium. So can potassium replace lithium? No. So my answer here is no. And why? Because K is below Li. I like to keep the convention of doing the single element first. It just makes it easier. You could, I guess, also say because Li is above K, but that just gets really confusing, especially when we're trying to grade this in class. Okay. All right, next one. F2 and Cl and HCl. So who's my single element? All right, so remember, fluorine's diatomic, but it's still the single element, right? It's the thing that's not paired with something else. Fluorine's paired with itself currently because it's diatomic, but it's not paired with something else, so it is still by itself. What's the charge of the thing by itself? Fluorine is a halogen, so it's negative. So what's it trying to replace? It's got to try to replace chlorine, right? It's got to replace the thing that is also negative. So now I need to compare those two on my list. So when I look at my list, here's fluorine, here's chlorine. Will this work? Yes, because fluorine is above chlorine. And it does not matter to me if you put it as, yes, F2 is above Cl2, or if you put F is above Cl. It's the position. I don't really care if your justification has the diatomic on it or not. The point is that you knew the fluorine was above chlorine. All right, last one. Who's my single element? It's potassium, right? It's the thing that's not paired with something. What's the charge of potassium? It's positive. Who's it trying to replace? The aluminum, which is also positive, right? Positive replaces positive. So let's look at our list. Where is potassium in relation to aluminum? So potassium, there we go. Potassium is right here. Aluminum is right here. So potassium is above aluminum. So will this work? Yes. Why? Because K is above Al. So before we go on to the next type of example, this last one that I just showed you, the only difference between this and the other three is that I wrote the single element second. You're doing the exact same thing. The order that I write these in has nothing to do with anything. Identify the single element, identify the charge. Who's it trying to replace? That's what you're asking yourself, right? The other type of question that I could ask you about activity series with gets in a little bit more practice with balancing. So predict and balance the following reactions, and then tell me, will the reaction actually occur? Justify. So it's just another way of me sneaking in some more balancing equations practice at you. Predict and balance. We got to do that part first. So just like we did in our predicting products section, we're going to look at our charges. So Na is +1. Rb is also +1. OH is -1. This one's easy because they all have the same charges. Na is going to pair with OH. And then Rb is going to be by itself. And I don't need any coefficients because I didn't add any subscripts, everything is still 1. So that was the first part. That was the predict and balance. Now, will this actually occur? So I go back to my list. Who was my single element? Sodium. Who was it replacing? Rubidium. Can sodium replace rubidium? So I look on my list. Sodium is here. Ooh, rubidium is above it. If rubidium is above sodium, is this going to work? Nope. So my answer, in addition to my balance equation, is no, because Na is below Rb. Okay. All right, let's look at the next one. So we've got CO parentheses NO3 parentheses 2. So this is some sort of cobalt. Let's see, nitrates -1. So there's 2 of those. So cobalt has to be +2 here because the nitrate's -1. And we know silver is always +1. So who's my single element? Silver. Silver is going to pair up with the nitrate. So +1 -1, AgNO3. Cobalt's going to be by itself. Then I need to take care of my balancing. I have 2 silvers, so if I put a 2 here, that's going to give me 2 nitrates. I have 2 nitrates and 1 cobalt, so we're good. Will this occur? All right, go to my list. Find cobalt. Here's cobalt. Look down. There's silver. Silver's way down there. Side note, let's look at this for just a second. Look what elements are at the very, very bottom of this activity series chart. Silver, platinum, and gold. So think about why we use those particular elements when we're making jewelry. We don't want those elements to be very chemically reactive. I would be really upset if I was doing a reaction and all of the gold in my wedding ring just up and left, went and paired with something else. So the reason we use these metals in particular for jewelry making is because they're not very chemically reactive. Fun facts. Anyway, cobalt is here, silver is here. Cobalt is way more reactive than silver. Silver is not going to be able to replace cobalt. So in terms of that part of my answer, no, this does not actually occur because silver is below cobalt. All right, last example. So we've got zinc and we have some copper with phosphate. So phosphate we know is -3. So that means this has to be +2 copper because this is -3 phosphate. 3 times 2 is 6. 2 times 3 is 6. We know zinc is +2. So single element zinc is going to try to replace the copper and pair with the phosphate. So drop and swap, Zn3PO4 2 plus Cu. I've got 3 zincs, so I need a 3 here. I've got 3 coppers, I need a 3 there, and 2 phosphates, so I'm good. All right, will this occur? So zinc replacing copper. Look at our list. So where's my zinc? Zinc is here. Where's my copper? Way down here. Yes, zinc can replace copper because zinc is above copper. All right.